Hello, abstract algebra students. We will now bring closure on the lecture about closure. You have completed the virtual Fun Friday, and now I want to summarize the results that we have found. I'm going to show you this bullseye graphic that I showed you again at the end of the first lecture. You have a separate bullseye for each of the four operations: addition, subtraction, multiplication, division. Now, each of the 12 sets is a different sector of the bullseye. So we have the positive integers, rationals, reals, the non-negative integers, rationals, reals, the non-zero integers, all integers, rationals, reals, and the non-zero integers, rationals, reals. Now, these are filled in based on each different concentric circle being a different property. The first circle tells the commutative property, colored in yes if the operation is commutative, colored in red, and colored in gray if the operation is not commutative. So you see all the red on the addition and multiplication bullseyes, meaning those operations are commutative. All the gray on the subtraction and division bullseyes, meaning those operations are not commutative. The second circle is associative, orange meaning yes, and gray meaning no. So again, you see orange on all the addition and all the multiplication sets, meaning addition and multiplication are associative operations on all of these sets. And gray in the second concentric circle for subtraction and division, meaning those operations are not associative. The third circle is well-defined and colored in yellow when the operations are well-defined. All four of the operations are well-defined on each of the sets. So what that means is you see yellow in all of the sectors on each of the bullseyes. Now, our fourth property, closure, we are using the fourth concentric circle, and we are using green to mean yes and gray to mean no. Gray is sort of the universal no, and we're using rainbow colors for yes. So, for example, under addition, the only sets that are not closed are the non-zero ones, Z star, Q star, R star. Under subtraction, only the whole sets of Z, Q, and R are closed. The rest of the sets are not closed under subtraction. Under multiplication, you see green everywhere. Every one of these sets is closed under multiplication. Under division, I only see green for the non-zero rationals and reals and the positive rationals and reals. All of the non-negatives and all of the whole sets are not closed under division, as are the positive integers and the non-zero integers are also not closed under division. Now, on the last lecture, I said commutative, associative, and well-defined are properties of operations, because if they are true about an operation on the big set of reals, they are automatically true on any subset of reals. Closure is a little bit trickier. For example, R is closed under addition, but Q star, a subset of R, is not. R is closed under subtraction, but Z plus, a subset of R, is not. R star is closed under division, but Z star, a subset of R star, is not. So closure has more to do with the set than an operation. Just because an operation is closed on a larger set does not mean that it is closed on a subset. Just because a set is closed under an operation, let me say it more correctly, just because a set is closed under an operation does not mean that a subset of that set is closed under an operation. Okay, for your homework, You will write formal proofs for each of the things that are not closed. So each of these grays here, you will write a proof. But even though by my count there are 3 and 9 and 8, 20 grays, I claim you can do this with 5 different proofs. The trick is picking A's and B's that work for many different sets for an operation. For example, under addition, if you pick A equals 1 and B equals -1, that would work to show that Z star, Q star, and R star are all not closed under addition, because 1 and -1 are in all of these sets, and 1 plus -1 or 0 is not in any of these 3 sets. You will think through more examples and proofs of that nature on the homework. Okay, that is the end of the lecture on the closure property, the second lecture of 6 in the chapter on binary operations. Take care, everybody.